In this lesson, we're going to learn how to solve inequalities by using multiplication and division. So if we take a look at our first problem up here, we're going to notice that we have a coefficient in front of our variable. And whenever we have that, that means that we are multiplying. And to solve our problem, we need to do the opposite. So we are going to, instead of multiplying here, we are going to divide both sides of our inequality by the coefficient, which is 8. When we do that, remember 8 divided by 8 is 1, so all we have left is 1x, which we will just call x, is less than or equal to, and then 40 divided by 8 is 5. So our solution says x is less than or equal to 5. We're going to go ahead and graph that on our number line like we did in the last lesson. We're going to start with our solution number 5. And the first thing that I'm going to do is I'm going to put that 5 right here in for my x, and I'm going to say to myself, is 5 less than or equal to 5? Yes, because 5 is equal to 5. Because it is included, we're going to use a closed circle on the number 5 to show that that is one of our answer solutions. Then I'm going to put a little tick mark before the 5 and write the number 4, the number ahead of it, and the number after it will be a 6. And then I'm going to ask myself a couple of questions. I'm going to put this 4 in here for x, and I will say, is 4 less than or equal to 5? Yes, it is. So that tells me that all the numbers on this side of the number line are solutions to this inequality. Just to double check, let's go ahead and put this 6 in here. Is 6 less than or equal to 5? No, it's not. So that's a good reminder to show that none of the answers on this side of the number line will work. Let's look at our second example up here. This says x divided by 2 is greater than 7. Because this is a division problem, we need to undo it by multiplying. To show multiplication, remember we're using a set of parentheses on both sides of the inequality, and I will multiply by my denominator, which is a 2. 2 divided by 2 is 1, so I have 1x left. I'll leave that as just an x. Is greater than, and then 7 times 2 is 14. So my answer's solution set is x is greater than 14. Once again, let's draw our number line. 14 will go in the center. And then we ask ourselves by placing the 14 here for x. Is 14 greater than 14? No, it's not. So then I'm going to use an open circle at 14 to show that 14 is not included as an answer to the set. Draw in a tick mark and put the number before 13, the number after, which is 15, and then I'm going to substitute each of these in for x. Is 13 greater than 14? No, so I do not do anything on this side. Let's try the 15. Is 15 greater than 14? Yes, it is. So then I'm going to shade this side of the line to show that all of these numbers are solutions to this inequality. Okay, let's take a look at a word problem. Ling earns $8 an hour working at the zoo. Write and solve an inequality that can be used to find out how many hours she must work in a week to earn at least $120. All right, so we know that the total is going to be 120, so I'm going to put that off to this side. She's working 8 hours at the zoo, and so she's working she's getting $8 an hour. So we're going to take our 8, multiply it by our number of hours, and that's going to tell me how much money she makes. Now I've got to determine what sign goes in here. She wants at least $120. At least. This is the smallest amount she wants. So it could be an equal, but she wants to make sure that she is getting more than. So this part needs to be greater than 120. Can be equal to 120, but it could also be larger. So that's the inequality we would set up. Now this inequality here shows that we're multiplying, so we're going to undo it by dividing. We're going to divide both sides by the coefficient, which is 8. And 8 divided by 8 is 1, so I have h is greater than or equal to 15, which tells me that Ling must work at least 15 hours to make the 120. Could work more than 15 hours, but has to work at least 15 hours. All right, so that's what happens when we multiply and divide when we're talking about positive numbers. But there's a new rule that we need to talk about when we're multiplying and dividing with negative integers. When we multiply or divide an inequality by a negative number, our inequality symbol needs to be reversed in order for it to remain true. So let's take a look at what that's going to look like. Here we have a negative 2 times g. This is a multiplying, so we're going to undo it again by dividing. And on both sides, we're going to divide by the coefficient, which is negative 2. Negative 2 divided by negative 2 is 1, so all I have left on this side is 1g. I'll write that as just g. And now because I divided both sides by a negative 2, this inequality less than needs to change. It's going to be reversed to the greater than. 10 divided by negative 2 is negative 5. So my answer now reads g is greater than negative 5. So again, when you divide by a negative on both sides, the inequality symbol gets reversed. We can also go ahead and graph. We'll put our negative 5 in the center. First thing I do, substitute that here. Is negative 5 greater than negative 5? No, it's not. So I'm going to put an open circle at my negative 5. I have a negative 6 before it. I have a negative 4 after it. And I'm going to ask myself, put this negative 6 in for g. Is negative 6 greater than negative 5? Nope, it's actually smaller. So then I check on this side. Is negative 4 greater than negative 5? Which it is. So we're going to go ahead and graph by shading in this side of the line, and all of those will be solutions. Let's take a look at our second example. So here we have x divided by negative 3 is less than or equal to 4. This is a division, so we're going to undo it by multiplying. I'll put my set of parentheses on each side. And I'm going to multiply by the denominator, which is a negative 3. Negative 3 divided by negative 3 is 1. 1x is written as just x. Because we're multiplying both sides here by a negative number, my inequality, less than or equal to, needs to flip. It now becomes greater than or equal to. And then 4 times negative 3 is a negative 12. So x is greater than or equal to negative 12. And let's do one more graph here. I'm going to put my solution, negative 12, in the center. And the first thing I'll ask myself is negative 12 greater than or equal to negative 12? Yes, it is, because it's equal, so that becomes a closed circle on negative 12. I'll put a negative 13 before it and a negative 11 after it, and ask myself, first of all, on the negative 13, is negative 13 greater than negative 12? No, it's not. It's smaller. Is negative 11 greater than or equal to negative 12? Which it is, so we are going to shade in this side of the line again to show that those numbers are the solutions to this problem. So again, because we multiplied here by a negative number on both sides, our inequality symbol needs to be reversed and changed to its opposite. And this is how we solve inequalities using multiplication or division.